Hello everyone, welcome back from my channel. Today we are going to do the exercises from Cambridge Primary Science Workbook 5. 3.1 Gases. Focus. Look at the picture of a glass of soda. Number 1. Write the labels for solid, liquid, and gas in the correct places on the picture. Number 2. Use the words in the box to complete the sentences about the states of matter. Vinegar, oxygen, states, rock, particles. A. Solid, liquids, and gases are the three states of matter. B. All matter is made of tiny particles. C. Oxygen is an example of a gas. D. Rock is an example of a solid. E. Vinegar is an example of a liquid. Question 3. Air is a mixture of gases. Say why this is so. Air is a mixture of gases because it is made out of the gases nitrogen, oxygen, carbon dioxide, and water vapor. Practice. Question number 4. You have particles of matter. Draw the particles in each box below to represent a solid, a liquid, and a gas. Question 5. Fill in the table to describe how particles move in the different states of matter. States of matter. Do particles move a lot, quite a lot, or hardly at all? Do particles move apart, move far apart, or shake in one place? Solid, hardly move at all, shake in one place. Liquid, move quite a lot, move apart. Gas, move a lot, move far apart. Challenge. Look at the picture of particles in the two syringes, A and B. Question 6a. Which syringe do you think contains water and which syringe contains air? Syringe A contains water and syringe B contains air. Question B. Explain your answer using the particles model. In syringe A, there are many particles close together, but not as tightly packed as in a solid. In syringe B, there are fewer particles and they are far apart as they are in a gas. Question 7. If you hold your finger over the open end of the syringes, which plunger will be easier to push down? Use the particle model to explain why. The plunger of syringe B. There is a lot of space between the gas particles. When you push down the plunger, the particles can move into the empty spaces. This makes gases easier to compress. 3.2 Properties of water. Focus. Choose the correct answer to each of the questions. Draw a circle around the letter of the correct answer to each question. Number 1. Which process makes ice become liquid on a hot day? B. Melting. Question 2. Which answer shows the process of melting? C. Solids plus heat becomes liquid. Question 3. Which answer shows the process of boiling? C. Liquid plus heat becomes gas. Question 4. Which of the following does not happen when we freeze water? B. It contrasts. Question 5. Your teacher heats a pan of water. When the water temperature is, which point has the water reached? D. Boiling point. Practice. Aaron put a block of ice on the saucer. Question 6. Make a drawing to show the ice cube after A. 2 minutes, B. 10 minutes. Question 7a. What has happened to the ice? It has melted. Question B. Why did this process happen? It melted because the solid ice particles gain enough heat energy to escape from the solid and change into liquid water. Question 8a. At what temperature does this process start to happen? 0 degrees Celsius. Question B. What do we call this temperature? Melting point. Challenge. Sophia's class investigated boiling. These are their results. Question 9. What do we call the temperature at which a liquid boils? Boiling point. Question 10a. Which liquid boils at the highest temperature? Milk. Question B. At what temperature does pure water boil? 100 degrees Celsius. Question 11a. Does water always boil at the same temperature? How do you know this? No, the tap water, salty water, and sugar water boil at a different temperature to pure water. B. Use the results to suggest a reason for this. When we add other substances to water, such as salt, it changes the boiling point of the water. Question 12. Why can you cook a hard-boiled egg on Mount Everest? You may have to do some research to find out. On Mount Everest, water boils at about 70 degrees Celsius. Egg yolks cook hard at 65 degrees Celsius, but egg whites must reach 85 degrees Celsius before they become hard. So, the egg yolk will cook on Mount Everest, but not the egg white.